Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
Hello everyone. In today's lecture, we'll be discussing resistance, its series and parallel combination, and electric power. Now let us understand what do you mean by resistance. Now these terminologies we are going to use again and again. So we have to understand these small points. Now basically resistance is a property which opposes or resists the flow of current. Fine, and this is how we are representing the resistance. The symbol of the resistance is shown and the SI unit of resistance is ohms. Okay, now a very important law is there which gives the relationship amongst resistance, voltage and current. Now what is Ohm's law? Ohm's law states that the current passing through any conductor is directly proportional to the potential difference. Now what is potential difference? Potential difference is voltage. Fine. So Ohm's law says that current is directly proportional to voltage. Okay. What else? Next it says that the current is inversely proportional to resistance. What does that mean? That I is inversely proportional to R. Fine. So together I can write that my current is directly proportional to V and inversely proportional to R. Okay, or in other words I can say that V is equal to IR. This is another way in which we can represent Ohm's law. One more way is that Ohm's law states that the ratio of potential difference across a conductor and the current. It means ratio of potential difference is V and current is I. So it states that this ratio is always constant. Now when I say it is constant, actually that constant is nothing but R, resistance R. Fine. So this is also giving the same equation V is equal to IR. Now we have to remember this particular equation always. Fine. V is equal to IR. Now let us understand how these resistances can be connected. If you have more than one resistance, then how can we connect it? Now they can be connected in two ways. One is the series connection, another is a parallel connection. So one is the series connection, another is a parallel connection. Fine. So in the first way, series connection is shown. And what will be the total resistance? Total resistance will be simply the sum of all individual resistances. Fine. Now important point here is, now how will I identify that what is series connection and what is a parallel connection? So here you should remember that every component has two ends. Fine. Two ends are there for every component. Like suppose this is a resistor. Fine. So this is one end and this is another end. Let me take one more resistor. This is one end, this is another end. Now suppose only one end is connected, one end of each component is connected together, then it is known as series connection. Fine. Now let us understand then how will be the parallel connection. Now as I said, suppose this is a resistor, this is one more resistor. Now if both the ends of these components are connected together, then this combination is known as parallel connection. So if only one ends are connected, series. If both the ends are connected together, then it is a parallel connection. Fine. So you should remember these points. Okay. Now let us come to a very important point which says that current is always same in a series circuit, but the voltage is divided. It means whatever current flows through R1, the same current flows through R2 if they both are in series connection. But the voltage gets divided between R1 and R2. Okay. Now let us come to parallel connection. Now parallel connection, how the parallel connection looks like has already been explained. Now let us understand what is the equation for it. So in parallel connection, the total resistance is represented as 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. So when you take the LCM of it, so you get 1 upon Rp is equal to, the LCM becomes R1 R2, okay, and here you get R2 plus R1. So when you take reciprocal of this equation, you get Rp is equal to R1 R2 upon R1 plus R2. So this is how we calculate the parallel equivalent resistance. Now again, important point is that if we talk about the voltage in parallel circuit, the voltage is always same, but here the currents get divided. It means whatever voltage is applied across this parallel combination, the same voltage appears across R1 and R2. Okay? But if you talk about the current gets divided. So if this is current I, it gets divided into I1 and I2. Fine? So here in parallel circuit, the current gets divided, and in series circuit, the voltage gets divided. Okay? Now let us understand what is power. Now basically, electrical power is defined as the rate at which the work is done. And numerically, the power is represented as the product of voltage and current. And there are some other ways to represent the power as well. Now how do we represent that? So by Ohm's law, we say that V is equal to IR, or I can say that I is equal to V by R, right? So I know that power relation is V is equal to IR. Okay, and I know that power P is equal to V into I. Fine. So what I will do is, I will keep the value of I here. So V into what is I? V upon R. So in this way, I get P is equal to V square upon R. So this is the first relation. Secondly, again P is equal to V into I. So here what I'll do is, I'll put the value of V. What is V? I into R, okay, into I. So I get P is equal to I square R. So these are the two relationships for power. One is in terms of voltage and another is in terms of current. Fine. And the SI unit of power is watts.